first part of 6.2, trigonometry of right angles. Basically, we're going to cover the basics of trigonometry again, and then kind of begin getting into how to apply those in future formulas. Okay, so here's a basic right triangle, and you're going to be drawing right triangles part of the day-to-day, and you're going to be given different pieces of the triangle. So we have alpha, we have beta, we have x, y, and r, opposite, adjacent legs, and hypotenuses. Okay, so we have SohCahToa up here. You learned that in Algebra 1. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. But you need to make sure you really grasp this and have this mastered, because it does depend on which corner of your triangle you're dealing with. Okay, so let's just go over the basic part of it, and then we'll start applying. If I say the sine of alpha, that means I'm starting at this corner. And that means I want the opposite over the hypotenuse. So the opposite leg. Hypotenuse is not a leg. Okay, you have an adjacent leg or an opposite leg. The hypotenuse is never considered a leg. So the opposite leg over the hypotenuse. In this case, opposite of alpha here is y over r. Okay. What is another trig function that is the reciprocal of the sine function? Cosecant. Okay, cosecant of alpha, which is just the reciprocal. Okay, so really, most of what you need to know today and from here on out is just sine and cosine functions. I'll tell you why when we get to tangent. Okay, so cosine of alpha, the cosine from this this corner is going to be the adjacent leg over the hypotenuse. The adjacent leg, adjacent means it's touching it, x over r. So adjacent leg over hypotenuse is x over r. And what's the reciprocal called? Secant. Because sometimes they're going to give you the secant, or sometimes they'll give you the cosecant, and you got to know how to apply them into a triangle, or do the reciprocal and then apply that in the triangle. Okay. So the secant here is going to be the reciprocal. That's r over x. So far you only need sine and cosine because you just take the reciprocals to get the cosecant and the secant. Tangent is the same thing as sine over cosine, because the tangent, we'll do alpha here, is y over x. The tangent is the opposite leg over the adjacent. From alpha, we go the opposite leg over the adjacent, y over x. And from our unit circle, the sine value is your y, and the cosine value is your x. So if you only know sine and cosine, you can do all 6 trigonometric functions. Okay? So the reciprocal of the tangent is going to be cotangent of alpha, which is just the reciprocal of what the tangent is. Very basic stuff. We had this in algebra. We went through that pretty quickly, but it should be familiar to you. We also did it at the beginning of the unit circle. All right, let's do some examples, all right? So in example 7 here, we're given a right triangle, and we want to know the theta of this corner. We want to solve the triangle here. We want to get this other piece that's missing here. Let me make sure we have all 6 functions here, all 6 trigonometric functions. So that means we got to know this value here. All right, we have this corner, and we have an adjacent leg and the hypotenuse. So which function deals with the adjacent and the hypotenuse? Okay, that's right. So we can find the cosine real quick. Cosine of theta is the adjacent leg over the hypotenuse. You can't leave a radical in your denominator unless I ask for it, so you got to rationalize it. You'll get 3 radical 13 over 13. Now what's the other function that goes with cosine? Secant. So quickly, secant of theta. Instead of taking the reciprocal of that answer, why don't we just take the reciprocal of this, and we have the radical on top of it. It goes pretty quickly after you find the third value. Well, we're done at this point unless you can tell me what this is. How do I figure out what y is? That's right. A squared plus b squared equals c squared. All right, so the Pythagorean theorem is what we're going to use here. This is a squared, that's b squared, that's c squared. So we have 3 squared plus y squared equals radical 13 squared. And then solve it, please. So just copy down what I'm going to try to solve it. You're going to have to do this on your own. Okay? Alright, so this is 2 here. Now we can do these other ones. The sine of theta. Sine of theta is what? Talk me through it. Opposite over hypotenuse. So 2 over radical 13, same type of thing. You got to get rid of the radical in the denominator. Good? Rationalize it. So today when you're doing your homework, just leave everything in radical form. Unless it's asking you for decimal places, okay? Alright, and then reciprocal to sine is what? Secant. Cosecant, sorry. Which is radical 13 over 2, so it's just the reciprocal of this. So on the test, I'm going to give you something like this, and I'm going to say, solve it. Give me all the trig functions, and each of these is a point. Okay, so there's like 30-some points on the test. That's 6 points, easy points that you don't want to screw up. All right, make sure you do it right. All right, then we have tangent. The tangent of theta is opposite over adjacent. That's 2 over 3. Notice just in general, if we did sine over cosine, 2 over radical 13 over 3 over radical 13, that we get 2 over 3. You're going to want to use sine over cosine at some point. Alright, and then the cotangent is just the reciprocal. It's pretty simple. You just have to push your way through using Pythagorean theorem, find the third side, and then work out your pieces. But you got to make sure you got this. This is something you should have mastered. Alright? Get there. Alright, on example 19 here, we're just finding x at this point. Alright? So, many of the problems that you're going to have is, what pieces have you been given? That's going to tell you which trig function to use. So here is the degree. You could find this degree if you didn't like using this position, because you know that this is 90 degrees already. But since they gave us this one, we have an adjacent leg and an opposite leg. Which function deals with those two? The tangent. So let's use the tangent of 36 degrees equal to the opposite leg over the adjacent. And then it just becomes algebra at this point. Going to solve for x, but it's in the denominator. So what do we need to do? Multiply both sides by x to get it out. And then to get x by itself now, what should we do? Divide off the tangent of 36. And use your handy-dandy calculator. Okay? And just make sure you're in degree mode. We're dealing with degrees, right? We're dealing with degrees. Make sure you are in degree mode. 12 divided by the tangent, 36. If it tells you go out 5 decimal places, go out 5 decimal places. If it doesn't, go out, if you're doing trig functions, go out 4 decimal places. Typically, if we're just doing a side, you just do to the tenths. Okay, so you could have just said 16.5. But if it asks you to do something, make sure you go out that many decimal places, okay? So if you're finding degrees with trig functions, go out 4 decimal places unless it says different. If you're finding a side, just use to the tenths. Just a general rule, okay? 21. There's only one problem in your homework that's like this, but this is important, so make sure you can do this. This is leading us into the point where you're going to be manipulating your trig functions in a way that you can solve different things, okay? So just kind of go through the motions of understanding how to do this. You can't solve for x and y. Yeah, I don't have enough information. Okay, what I want is you to give me an equation where you only have y in it, and I want an equation where you only have x in it. So you're going to give me two equations up here. So if I'm going to solve for y first, and I don't want x, and this is the corner I'm starting with, I don't want to use a trig function that has the adjacent side in it. So what trig function only uses the opposite leg and the hypotenuse? The sine. So you're going to say sine of theta equals y over 28. And then solve for y. What do you got to do? What? Yeah, multiply by 28 on both sides. So y equals 28 sine of theta. Okay, now, I want to solve for x. What function do you think we're going to use just for x? Y cosine. Yeah. With this corner, we want the adjacent leg and the hypotenuse. We don't want to use the y. So we're going to use the cosine of theta equal to the adjacent leg over hypotenuse. And this one happens to solve the same. So x equals 28 cosine of theta. They don't always come out like that. Sometimes you have to move your variable out of your denominator like what we did here. Okay? And so now you have two expressions and two unknowns as well, okay? How we doing? Hanging in? Not too bad? All right. The next part is solve this without a calculator. So this is unit circle type of stuff. Just real quickly, 30-degree angle on your unit circle. That's your short leg, that's your long leg. 60-degree angle. Okay, so sine of a 30-degree angle is your y value. So what is that? What's the y value at 30 degrees?
Is it half?
1/2. As long as I don't have to quiz you on your unit circle again. So this is 1/2. The cosine at 60 degrees. What's the cosine? What's the x value at 60 degrees? 1/2. Okay, now what's the y value at 60 degrees? Radical 3 over 2, very good. And the x value at 30 degrees? The long leg is radical 3 over 2. Okay, multiply these together, that's 1/4. Radical 3 times radical 3 is what? Radical 3 times radical 3 is 3. 2 times 2 is 4. 1/4 plus 3/4 is 1. This is actually from a formula we're going to learn later on. And then the last example that I have down here, this part right here, the a and the x minus a, are not in the problem. Now don't blow this off, because this is going to happen. Okay? It's going to happen on Monday's homework assignment as well. I don't have, if I get rid of this so you can see what the problem looks like. If this is my problem, okay, I got to figure out what x is, except it's split into two different areas. And the only way really to solve this is to make two equations and two unknowns and use substitution. So what you're going to do is you set one length equal to something, I'll say a, and this one would then be x minus that length. So now I'm going to use trigonometry to come up with two equations and two unknowns. So I have 60 degrees here, so here's my triangle. What trig function am I going to use that deals with the adjacent leg and the opposite leg? Tangent. So the tangent of 60 degrees is equal to the opposite leg over the adjacent. Now we can solve for a here, so let's go ahead and do that. Multiply both sides by a, and then divide off the tangent of 60. 100 divided by the tangent of 60. So everybody figure out what that is. Yep. Okay, 57.73502. Okay, so now we know what A is. Now let's do this triangle here. With this corner that we've been given, we have the adjacent leg and the opposite leg again. So that's going to be tangent again. The tangent of 30 equal to the opposite leg over the adjacent leg, x minus a. Now we have two variables in this equation. So we want to solve, we know what a is, we can put this value in for a now, if you want to. But we got to get x out of the denominator, so we're going to multiply both sides by x minus a, or 57.7 times the tangent of 30 equals 100. So it's just algebra that you're doing here. But the process is that you understand you're going to have to make two equations. Well, let's divide off the tangent of 30 instead of distributing here. X minus 57.7 equals 100 over the tangent of 30. So everybody figure out that one. What'd you get? 173.2. Okay. And then solve for x. Add 57 to that. What do you get? 230 something, right? Okay, so the point is, you divide up into the two different triangles, but you got to set up this type of thing, okay? Set them up, and then you just do an algebra at that point. You don't have to leave it in tangent form. You can go ahead and figure out what those numbers are and just put the numbers in, if that makes you feel more comfortable. But then you got to actually solve it down algebraically after that. All right? Any questions? Awesome.